Okay, hello everyone. So today is the second session for our time zone. We're gonna go a bit deeper in some concepts. 1 second. Okay. So the idea today is to cover a few sections of the training material. So we're going to talk about channels in more details, processes, operators. We're going to have a break. Then we're going to talk about modules, the config file, the configuration of the pipeline with Nextflow, and some deployment scenarios. Okay. So yesterday it was a bit intense. We saw like a full RNA-seq pipeline. We went to so many concepts. We mentioned channels, we mentioned processes, we mentioned operators. And at the beginning, I had warned you not to focus or worry too much about these details, because later they will be explained in more detail. Okay, so basically that's what we're going to do today. So we're going to talk about channels again, but much deeper, processes again, much deeper, and then operators. I will try to slow down, probably going to do this in more than 1 hour. I'll try to focus to make sure it's really clear, this part to you guys. And then we're going to talk about modules, network, Nextflow configuration, and the deployment scenario. Okay, so we're back in Gitpod. Today is taking a bit longer to load. So I mentioned in the Slack channel that before the training, we should already try to start it to make sure it will be ready when the training starts. I think a good thing to do probably is to look at the final RNA-seq pipeline script that we did yesterday, which is this one. I'm going to increase a bit the font size here. So very quickly, so that we don't lose too much time with that, go over what we did yesterday, just to as a review. So we have some parameters here. So when we have this params dot is like a keyword, it means that we can pass with 2 dashes some information to our pipeline with Nextflow. Okay, so we have a read, we have the transcriptome file. We're using this environment variable from Nextflow project here, which is where the NF file is located. Okay, we have it out there. We use log info to print some nice information to the command line. When the user runs our pipeline, they're gonna know which transcriptome file is being used, which reads, the folder for output, results, and so on. We have a first process, which is index, which is going to use Salmon to generate an index based on a transcriptome file that we're going to provide. And then this is going to be stored in a folder called Salmon_index. The next process that we have is a quantification one, which is going to perform quantification again with Salmon. We're going to give a tuple, which here is a file pair. We have an ID like gut, liver, lung, and the reads. Here we have pair and reads. So we have 2 reads for every of the samples. And we're gonna save this to a folder which is the sample ID name. So because we want to do this dynamically, we want to, every task, depending on the sample and the sample ID, is gonna create a different folder. We're gonna use this double quotes and the $sign to make sure this is a variable here, okay? Then we have the script block calling Salmon. Then we're gonna use FastQC to do quality control with our samples. And then multi-QC to generate a full report of everything we did in the pipeline. But at this point, these processes, they're not connected, they're just described. We're going to use a workflow block to connect everything. We're going to create a channel. We're going to use a channel factory called from file pairs. We're going to have these reads. We're going to check if they exist. So if they don't exist, the path, there's no reads or anything, Nextflow is going to have like a beautiful Nextflow message about this. And we're going to start that to reparse CH. So we learned yesterday that actually this is the same thing. But a lot of people have been using this style of at the end adding the variable where this is going to be stored. And like in the R community, if you write code in R, you know, it's very common to at the end use some operator to save all the computation to a specific variable. So basically that's what we've been doing with Nextflow. Then we're going to call the index process and save in this channel the output, then call the quantification process with the output of the previous process and the samples. Then we're going to use the FastQC process to check the quality of the samples and save here. And then we're going to pass everything to MultiQC. So we're going to get this channel, which is the output of the quantification process. We're going to mix that with the FastQC process. So what's the mix operator again? So the mix operator is going to just put together different channels as if they were one. So actually, we're going to talk about this soon, so it's better to save that for later. And then we have this handler here. So when the workflow is complete, no failure, no error, it's going to write to the, when it's finished, if it's successful, no error, no failure, it's going to write down, open the following report in your browser, blah, blah, blah. You're going to use this expression here with, if this is true, do this, otherwise, the column here separating them, say this. Oops, something went wrong. So now that we went over the whole pipeline that we wrote yesterday, let's start looking at things in more detail, starting with the channels, okay? This is section 5 of the training material. So the idea here is that we're going to always have a task at some point. At the beginning, we only have the channels, right? Which we are providing as inputs to our tasks, to our processes. Again, process is a definition. When it's run, it's a task. So usually we're going to have a task alpha here, for example, is going to have an output, which is a channel with one or more elements. Here we have files. So we have file Z, Y, X. And this, which is the output for the task alpha, is going to be the input for task beta. And then it keeps happening. But what's a channel? So we said before, basically a channel is a first in, first out queue. So the first element to be added to the channel will be the first one to be run, to be passed to a task, to a process. They are non-blocking, they are unidirectional. But we not only have queue channels, we also have value channels, okay? So here, just one example, we're gonna create a channel. We're gonna use the of factory. So what are channel factories? Are operators or functions that help you create a channel. So here we want a channel with 3 elements, 1, 2, and 3. So let's create a script here, test nav. Let's try to let's open it here. That's enough. Let's split so you guys can see everything. Oh, then I lose the other part. Was 5 channels. So what we're going to do here is that we're going to create a channel with 3 elements, 1, 2, and 3. And we're going to store this to a channel named ch. One thing we can do is to use the println function to print the content of that as a variable, because channels, there are variables. But then we can use the view operator to really see the channel, which is more high level, let's say. So we can do Nextflow run test and nav to see what happens. And we see here what's inside, which is the println function. It's not very understandable to us because that's how Nextflow is handling these things. What we care actually is what's inside the channel, and that's why that's what the view operator does. Show that there's 3 elements, 1, 2, and 3. They are shown here in separate lines because the view channel, it prints in your standard output every element once at a time. If we had something like this between brackets, this is a single element. So this channel has 1 element, which is a collection of 3 values, 1, 2, and 3. If we run it, we have 1 line, 1, 2, 3, because this is 1 element. One interesting thing we can do is to use this parameter here, dash DSL1. So again, because we have 1 dash, we know that this option, this parameter, is for Nextflow. If we had 2, it would be for the pipeline. So here's for Nextflow. By saying this, I'm saying that I want to run Nextflow with the older standard for the language. This is not what we should do, but there's one very interesting thing here that helps us understand what is a channel. So I'm going to run this for you. Same script, but I want to interpret it with DSL1. By doing that, when we have the println, which prints what's inside the variable, we have a very interesting structure. So we have a queue, which is a queue channel. We know that. There's 1 element, which is 1, 2, 3. And we have a poison pill. This poison pill tells the process that the channel has been consumed and it's over. There's nothing else to consume. If we had 1, 2, 3 as before, which is a channel, a queue channel with 3 values, 1, 2, and 3, we're going to have now something similar before, but with more elements. So now we have a queue channel as before. We have 1 element, which is 1, 1 element, which is 2, and another element, which is 3. And again, the poison pill in the end. What if we want a value channel? So instead of using the of factory channel factory, we're going to use value. And they are value channels, they are singleton. They have only 1 element. So I'm going to put the brackets back because there's going to be 1 element. I'm going to save again to CH, and let's see what's inside now. Now something interesting is going to appear. When we had a queue channel, we had the poison pill at the end. Now we don't have the poison pill anymore. We just have the value. This means that the way processes consume this channel is different. Usually you won't use value channels explicitly, because actually implicitly it's already used. So when we were using the script 7, oops, so let's open it here. When we were using the script 7 yesterday, we had, for example, this parameter, which was the transcriptome file. So it's just a string that has the path to the transcriptome file. And when we call it in the workflow, we gave it as an input to the index process. But if we go to the index process, it expects a channel that contains a path. But we didn't create a path. We didn't create a channel. We just sent a string. What happens here is that when we do that, automatically behind the curtains, Nextflow is going to create a value channel, store this value, and pass this value channel to the process. That's what's happening here. So even if you don't use value channels, they are automatically used by Nextflow. But there are some situations in which you have to use value channels. And I'm going to give you one example here. So as I can go to the test, I'm going to create 2 channels, which is going to be 1, 2, 3, and 4. And a second channel, which is going to be 1, 2, 3. So these are 2 queue channels, right? We have here the channel factory of, which creates a queue channel. We're going to create a process here, which is sum. It's going to get as input a value X, a value Y. The output is going to be std out, which is the standard output. It's just going to print to the screen. Okay. I'm going to put the book true because then I want this output to be seen. I have a script block. We don't have to keep typing script. By default, it's already script. So let's take it out here. And I'm going to do this. This is just bash script, shell script to sum 2 variables, okay? I'm going to create a workflow. Actually, I'm going to start like this. Now I'm going to create a workflow block. And I'm going to call sum with ch1 and ch2. Let's see what happens. So again, I have 2 queue channels. I create a process to sum them. What's happening here? Okay. So the thing is, we have to escape the $sign. Otherwise, Nextflow is going to try to interpret it. And we want bash to do that. So again, all the questions that you have, you can, it was an extra double quote here. You can ask on Slack. So Rob and so many others have been helping us yesterday and today. So feel free to ask any question during the training or in the breaks or even after the training. So these 3 days, the channel is there for you, the Slack channel. So here what we did basically was to sum 1 + 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, 8. They don't have the exact same order because there's no guarantee they will be the task will finish in the same order with the same amount of time, but we have here the right outputs. Okay, that's good. But then what happens if we do this? Now we have a channel with 4 elements and a channel with 3 elements. When this happens, something interesting is going to happen. When we have this setting, something interesting is going to happen. Basically, because we have the poison pill, as you saw before, when the last element, I mean, the process sum is expecting 2 values, right, from 2 channels. At the when it's finished with 3 and it goes to the 4, CH is going to send 4. CH1 is going to send 4 as a value, but CH2 is going to send a poison pill. And by receiving a poison pill, the process sum ceases to work. And that's why here we have 1 plus 1, 2 plus 2, 3 plus 3, and then we don't have anything else. Sometimes you may want things to still keep working. You don't want the poison pill to stop the execution of your task just because there are no values anymore in one of the channels. One way of doing that is you can just have a value channel. So here we have only one element, and okay, let's do it like if it was off, it will end here. So let's do this. I think it's more didactic to do everything. So here we're going to have only 2, because when the first channel sent the value 2, there was a poison pill here and it was over. But if we use value, we create a value channel, it doesn't have a poison pill as you saw. And then what's going to happen is that all the elements of channel 1 is going to be summed with 1. So we have 2, 3, 4, and 5. So this is one case in which we want to use the value channel, a value channel. But usually you don't do that. You just go with the Q channels, okay? So we were talking about channel factory. So we have the value 1 to create a value channel. We have the of 1, which is the most common one to create Q channels. And in training, in the session yesterday and today, probably you saw this thing about having, where is it? The test here. This thing of having the curly braces. And why we have these curly braces? Why we have these curly braces? So they can be useful for many things. So let's create a new channel again. 1, 3, 5, 7. No, again, spaces, all these things are just a matter of style. You're free to use it the way you want. If we do it like this, we're going to have just the content 1, 3, 5, and 7. If we use the curly braces, we have to say it, which means like get the channel and every element, just I want to have it. So it. We're going to have the same output. When you have the curly braces, you don't have to use the parentheses. They are optional. So here I use them, but I'm going to remove them afterwards. We don't need it when we have the curly braces. The nice thing is that one thing you can do is to play with it, with every element of your channel. So here I want that every element of my channel I'm going to multiply by 2. Or you could just make it a string and play with that. Like here we have value, and then you have that. So we're going to have a string value before the name, the element of the channel. And because it's within a string, we have to use the $sign. Then we're going to have this output here. A nice thing is that the of channel factory also allows range. So you can use these 2 dots to create a range. So I want a channel with all the numbers from 1 to 23, and then I want X, and then Y, and I want a collection of I's, and so on. You can do everything here. From list is a not very used operator, channel factory. Basically, if you have a list of values, like a collection like that, you can use from list to turn this into a Q channel, okay? From path, we've used before in the pipeline yesterday. So basically, you're going to create a Q channel with a path. Here, you can use globs. This asterisk means that I want all the files inside data inside meta. You can also use 2 asterisks. In this case, the 2 stars, you can have not only every CSV file in here, but also inside folders that are inside meta. So you want to go through subdirectories. There are some parameters that you can provide to the from path channel factory. So hidden files, type of files, if you want files or directors or any, the depth of these subdirectors that you want to visit. If you want to follow links or not, check if they exist. There are many parameters for many of the channel factors that you can use. Here, for example, I want all .fq files within this path and also the subdirectors here. And I want to include hidden files. From file pairs, we've seen that yesterday also. So you can give this glob here with start, say all these files here that end with FQ and have 1 or 2. And file pairs automatically we will know that it's going to be it's going to collect in the form of a tuple. With the first element it is a simple ID, like this name of the file, and the second part of the tuple is a collection of files. In this case, 2. So here's one example of what we saw yesterday. This shouldn't be new to you. So liver, there was 2 samples, gut 2 samples, lung 2 samples. Again, we have some parameters for the from file pairs channel factory. In this case, flat. So you can match files, so elements and emitted tuples. There are many things you can do. So it's very interesting that it will be very nice after the training. You come back to the training material, you read it again, you try to get more to details and even to check the official documentation, which has many more channel operators and channel factories and so many other tools that you can use with Nextflow. One very interesting one is from SRA. So here, basically, you have to set to configure Nextflow to use your API key with NCBI. But when this is all set, you can just give an SRA ID with your API key, and Nextflow will download the data and automatically create a channel with the path to the samples of this ID that you provided. This still works, but there is a pipeline specifically for that called Fetch NGS. And probably tomorrow in the NF Core training, you're going to see that it's an NF Core pipeline. So maybe this Fetch NGS is preferred over the from SRA, but you have this channel factory. And again, you can have many IDs, and then you're going to have a channel with the IDs and the location of the samples of every ID. Here's just one example where you would use have only one process, which is FastQC, to do quality control with samples. And in your workflow block, you already start by collecting with the from SRA the samples and calling FastQC. So it's much simplified. This is a question that I think someone asked yesterday in this training, or maybe it was the other time zone one. You have a text file and you want to play with it. So here we can use the split text operator. We can use the from path channel factory, but then when we have a channel, then we're gonna use split text to split this TXT document. By default, it's gonna split in a way that every line of the document is an element of the channel, and then you view it. But sometimes you don't want that. So here you're gonna use this parameter by to say that by how many lines you want to split the file. So here you're gonna split every 2 lines. So we can run that actually. Oops, first we need to in a file. We're gonna run that. And we're gonna have every 2 lines. But then if we're just doing that, you're gonna see the whole document because in the end it will show everything. So what we do here is to have this operator called subscribe, which basically is gonna do something to every element of this channel. And here what we decided to do is to print it. So we're gonna print the element, which is 2 lines of this document. But then we're also going to print a new line with end of chunk to make it clear to us the separation. So here you see we have 2 lines, end of chunk, 2 lines, end of chunk, 2 lines, end of chunk, and then 1 line because it's odd, the number of lines in this file, in this text file. But again, you see, we can use this subscribe to make many interesting things. So your creativity is the limitation for that. You can think about anything, and you can use subscribe operator. So here, for example, we're going to use by 10. So I want that every 10 lines of this document be an element in my channel. And then we can use this closure here. The same way we used with view before, we can use here with any operator. We're going to use it with split text. And then we want that every element becomes uppercase. Then if we replace it here and run it again, we're going to have the same thing, but with uppercase characters. But again, it's going to be 10 lines, right? Not every 2, but every 10. And as you see, everything is uppercase. You can do math if there were numbers. You can do reverse, uppercase. You can do many, many things with subscribe or with the closure. So the nice thing about subscribe is that you can have many lines in what you want to do. And here it's a bit more limited or not so readable, let's say. You can also do many different things. Again, we're using this closure here with view as we did before. Instead of doing just saying value and the number, we want to keep increasing the count. Starting with 0 is going to be 1 for the first line, 2, because we didn't say anything here, any parameter. So it's going to be every 1 line. And then we're going to have this count. We're going to get it, make it uppercase, and then trim it. So we can run this. I'm going to get so we're going to have our variable, which is count, being incremented every iteration, a colon, and then the value, which is going to be uppercase and trimmed. We can actually use that. We can also use the file. It's not really a channel factory, but you can create a file in the Nextflow language by providing the path, and you can still use split text and everything. Having a file like that's not very common, but one thing that is probably a lot more common is to have files that are separated by some symbol. So the CSV, which is comma separate values, is a very common text file, data file. So here we can just call the split CSV operator, okay? And we're gonna have the fields, we're gonna have a channel with these elements, and we can consume them based on the position of these columns. So I want the row for column 0, for column 3. If we open here, so it's a data meta. If we open this patient one CSV, we're gonna see this. So it's one field is patient ID, Jira ID, S3 dear, and so on. And we have the rows here. If you run that, we're gonna have the every row with the first column and the fourth column. Here we have patient ID and the number of samples. But then the position, right, of the column, that's not very nice. So if we have a header and we have names for the columns, I may want to use names. That's what we're gonna do with this code. So basically we have this parameter, which is header true. And then instead of saying the number, I want to say the name of the column, which is patient ID and num samples, which is the one we just saw, but we're gonna use, we were using 0 and 4. So now we're gonna see, again, all the rows, but I just want the patient ID's column and the number of samples column. And then we have again here. We can do the same thing. We can give a header if there is none. There are many things we can do. And again, the documentation is very large. You can check. There are many things you can do. Another thing that we may want to do is to work with Tsv files. So here we were just rewriting the code yesterday to work with this thing we learned. Here we can do the same thing with the Tsv files. We're still going to use a split CSV function, but the difference is that we're going to give this parameter, this option, which is sep for separator. And instead of a comma, we're going to do this, the reverse /t, which is a tab. So whenever we have tab separate values, we can use split CSV with this. option to read it. So let's see here, regions TSV. You see, it's not a comma anymore that's separating it. It's a tab. See, it's not a space, it's a tab. And by providing this /t here, we can do that. We can run this. And we have here every row with everything. But here they are table separate values. In the end, for Nextflow, they are converted to be comma separate values because it's split CSV function, but we provide what separate is being used. If it's another separator, we can also provide it here. And in the end, it's going to be inside Nextflow as a CSV. Again, we can give the header true to call the column by the name. And there are many other formats that we can use. So JSON, we have YAML. Here, I'm going to show the example with JSON. So we have this regions.json is another way of organizing your data in a text file. So here we have this brackets and curly braces and everything. So we can use this function, JSON slurper, with parse to parse this file, which is the JSON one. And then we can use this loop to get for every record and entry, I get the patient ID or the feature, which is these fields that we have here. Patient ID, region ID, feature, pass flag. So by checking, by consuming this, we get the value. You can run this so you can see it. How it's, you see it working. And we have it here, IDs and features, the way we asked here. So I won't lose time here with YAML because it's just a different format, but it's very similar. We still have a function, we still parse or load, we still have a loop going with the entry to getting these fields. It's the same thing. This part is teaching you how to create a module with these parsers and then call it to use in your pipeline script without having to write this part here. I'm going to skip that because we're going to talk about that when we are talking about modules in the next today. So now we're going to go to the processes, which is the second section we're going to do today. So we finished channels. Now we're going to go to processes. Then I think probably going to do a break, maybe before operators or during operators. And then we come back with modularization, the configuration, and deployment scenarios. So for processes, again, it's something that we saw yesterday, like many things we're going to see today. But the difference is that now we're going to see with more detail. So yesterday, basically, we saw processes that were very simple with input and output and a script block, sometimes even less than that. Actually, a process can be much more than that. So this is one example, like a simple process with no input, no output, just a script block saying hello world. But actually the block can have many more things. The process block can have many more things. So we have the name, we can have directives, which are optional. So we've seen some directives yesterday. So debug, published here, we saw CPUs, we saw container. So they're all directives that can come here or in the config file. And we're going to talk about this today. But for now, just bear in mind that you can have it here. We can have our input block, which we have all the channels that are going to be the input for this process. We have the output block, which has all the channels that are going to be the output of this process. We have a when block. So this when block tells Nextflow when this process should be run. So for example, one very interesting thing about Nextflow is that it can be very dynamic in the way things happen. So you may you can, for example, say that, okay, I'm going to have the samples, and whenever the sample doesn't reach a certain level of quality, I don't want the sequence to be aligned, for example, to a reference genome. And then you have all your samples, you're going to put in a channel, you're going to call the process align, and every sample that comes, every element of this channel that comes to this process is going to check something. Maybe the output of another process that was the quality of each of these sequences. If the quality is okay, the process is going to run a task the way it should, with the script block here. However, if the quality is bad, you just skip this sample. You go to the next sample. And then the next one, if the quality is bad here. So this is a simple example, but you can think about more things. The thing is, whenever this condition here is false, this task will not be run for this sample. So it's a way to use or not a process for elements of a channel. And then you have the script block, which is basically what the process is going to do. And we saw that a lot already. So here we have an example, which a lot of things happening. We have an echo. So by default, if you don't say what language is your code in the script block, Nextflow is going to understand that it's shell script. So here it's shell script. Indeed, we didn't say anything. So we're going to echo something to a file. We're going to get the content of this file. We're going to get the first line, the first 5 characters. We're going to save this to chunk1.txt. We're going to compact that to this. So we do a lot of things. There are situations which indeed your process is going to do a lot of things, but usually you have to have some common sense and maybe split into more processes. But the thing here is that you can have many lines of code in a single process. If instead of shell script, you want to use another language in the script block, you have to tell Nextflow which language is that. If it's Python, for example, you have to put the shebang that I told you yesterday was a shebang, yes, just to tell what software is going to be used to interpret this code. So here I want to use Python. I'm going to say it's Python. And then we run the script block. The thing is, sometimes this gets too long. I mean, you won't write a whole software in Python in this block. It's going to be terrible to read. And you should leave the pipeline file just for the pipeline details. If it's configuration, you do in the nextflow.config. If it's scripts, you create script files, you start the bin folder, and then you can just call the way we were calling yesterday salmon. We just say salmon and the arguments. Here we would say my script and the arguments. The parameters we already saw yesterday also, we just say params dot and the name. And then we can, by providing dash dash this name, when we are calling the pipeline, we can give a different value. So here, just going to print, I'm going to run it again, just in case someone forgot or feels a bit lost. So let's run this. If you don't say anything, it's going to use the default value that's already provided, which is world. It's going to say hello world. However, I could also run that by providing a pipeline argument with dash. Okay, we have to here. Either we use debug true here, so we see the output, or we can use dash process.echo. We also see it. Or we could use, if we had an output here, I could use view to see the content of the output channel. Here, hello world. We can also change that by calling again the pipeline, but now I'm going to provide a parameter, which is data, which is this parameter of the pipeline. And instead of world, I'm going to say Bob. And then the pipeline is going to run. It's going to override the default value, which is world, to Bob. And it's going to print in the screen, hello, Bob. Hello, Bob. There are many things we can do. One interesting thing, I'm going to show one thing here that is not so evident, but I think it's important to know. So let's run this. We won't see anything, but the interesting thing here is that there's something ran. So we have the hash here. So let's see what's inside. Work 1, 3. So I want to see the command sh. So here we have, so this is the file that Nextflow creates to run in the local machine, in the cloud, in your HPC cluster, wherever is your compute environment. So it creates this and then makes this be run, either submitting as a job to HPC cluster or anything. It's interesting to know that the working directory will be the one where the job will run. If we didn't have this escaping here with the reverse slash, something different would happen. Let's see what's going to happen. So again, nothing's going to be printed because we are not using process echo or debug or anything. But I want to see command sh again. So you see, now we don't have the variable anymore. Because we didn't escape, Nextflow understood this variable and replaced it by So PWD is like print working directory. So it got the working directory where we run it. If you want that, then you leave it like this. But if you want it to be where the process, the code is going to be run, the script block, you have to escape that with the reverse slash. So that's the difference here. So there are many different things you can do. Sometimes, so probably in some script, you've seen that we can have like, let's say we have an input here, which is val x. So here we would have x like this. If I want to print the content of x, I would do that. So this is a Nextflow variable. But maybe I would have something being set to x here. So how do we differentiate between variables that are variables in the code of our script block and variables that are Nextflow variables of the pipeline of the script file? So instead of using script, we can use shell. Oops. And by using shell, we cannot access Nextflow variables anymore with this. We have to instead use this format. And this way we know, I mean, Nextflow will know, and the interpreter will know that this is a variable from the code, the script block, and this is a variable from the pipeline. So this is one use case for using shell instead of script in the script block. Another interesting thing is that, so usually we say that you can only have one script block per process. And that's correct, because a process can only execute one script block per time. But there's one thing you can do, which is to have conditional scripts. So I like this example here. I think it's very useful and close to a real life scenario. So let's do it here. So basically what it does here is that we have a parameter for the pipeline, which is compress. The default value is gzip, so there's a gunzip to compress files. And the second file, the second parameter, it's a file to compress. We have a path to a file that we want to compress. We have the full process, which is going to be called, and the parameter is the file to compress, so the path file. But then there are different script blocks here. If you don't say anything, if you don't provide the gzip compress parameter, it's going to be the default. It's going to be the default. If you don't say anything, it's going to be gzip. And then in this case, that's the script we want to run, which is basically compressing the file by using gzip. However, if you provide a parameter with compress and it is bzip2, then it's a different script block that this process is going to run, which is the same thing, compressing a file, but we're going to use bzip2 to do that. And if you provide a file, a method that actually is not gzip or bzip2, it's going to throw an error. So we can do here test nav. I won't provide a file to compress because I'm going to use this default one, but I want to say a different map. So let's say gzip. I want to bzip2. I want to compress with bzip2. So this is going to work. And we can even see, so because we didn't say published here, we didn't choose a place for this file to be, but you can just go to the work directory and see that it's compressed here with bzip2. This is an intermediate file. It's not downloaded or anything, just a link to where the file really is, and we provide it here. It's here. But let's say I don't say bzip2, I say Marcel. Because Marcel is not gzip or bzip2, we're going to go to this condition, to the else, and we're going to throw an illegal argument exception. We're going to say there's an unknown here, really a liner here would be a compressor, but we get here this error. Now that we kind of understood the whole structure of a process, what we can do, oh, I should have closed that. So what we can do is to try to understand more about the inputs. So let's start talking about inputs now, the input block of a channel. So basically, that's a figure that I like a lot. So basically, you have a channel, you have every element of a channel and so on, and more elements can be arriving. So every example we have shown so far, they have a ready channel. When you call the process, the channel is ready. So you create a channel with 10 elements, or with all the files in a folder, and then you call the process. This is not always the case. You could have, for example, there's something called watch path, which is a so you can use this function to watch for a folder. So the channel is there, and the process is waiting for something. And whenever there's a new file in the folder, according to some globs that you're going to define, it's called to the channel, and then it's delivered to a process, and then more maybe arriving. So there are other ways you can do that. So what I want to say is that sometimes your channel is being created or filled while your pipeline is running. And the thing is, whenever there's a process that has this channel as input, whenever there's an element in the input, it's not a poison pill, the process is gonna run a task of that process with this element. And that's how the implicit parallelization works. We can always run the process with every element that's arriving. And again, this is requested to the operating system. So it really depends on the operating system or the HPC cluster with the job scheduler or the cloud provider service. So Nextflow may ask for 1,000 tasks, and maybe not all of them are going to take place. You can also control that, the rhythm of this number of tasks being issued. But the thing is, you have this task being issued and output channels being filled, and then next processes will receive this, and so on. So we've seen a lot of times already the input block being created. We have an input qualifier, a val, path, a tuple, and so on. And we have the input name, which is just a name you're giving to this input, so you can reference it later. So for value, here we have val x, for example, and then we can call it with $x and see what's going on. So again, you can see, oh, Marcel, I see there are spaces between the parentheses and the number in the channels. It's just a style. Just some people, they use space, some people don't use space, some people put everything together. It's just a matter of taste. Okay, because here there's no workflow block, it complains that this was used for DSL1 and now we have DSL2. So we do have to have a workflow block. If you get this error, this warning, it's because of that. I had forgotten to paste the workflow block. So now we have 1, 2, 3, which are the elements of this channel. Again, the order is not guaranteed. It's run in order, but sometimes due to many things in the operating system, some tasks they finish sooner and then they are printed to the standard output. So here we have a path. So because we have between quotes, it's not a variable or anything. It's specifically this path that we're gonna use. And we're gonna reference it here. See, we can use a path again here. I'm skipping some parts that are just repetitive. And again, you can ask the questions on Slack so that we can focus more on things that are different here from what we've already seen. So here I want, I'm gonna call it this, the input path. The output is gonna be top 10 lines, which is a file in this case. And indeed, that's the name of the file that we are outputting this first 20 lines of this file. We can also combine input channels. So by saying combine here, what it means is that a process can have more than one input. So here, for example, this foo process is getting two channels as input, which are values, a value x and a value y. Here we see that foo is being called with channel 1, channel 2. We already worked with some examples even today by doing that. A process that has many inputs, and you can also have many outputs. I think it's the next section. Okay, so this we already saw that when we have here, we're going to have the poison pill. So it's going to stop here. And then we have this example with value here. We can have input repeaters. So that's a very interesting thing. So I don't really like this example, but I think there's a better example here. So let's say that you have some samples. You have your transcriptome reference file, just like we did before with Salmon to create the index. But Salmon is not the only software to do that. Actually, you have another one, which is called Callisto. So let's say that I want my process to create index, but I want to create index with Callisto and with Salmon. So basically what I'm going to do is that I'm going to call the process command. with the channel that has the files. Here the reads. Okay, 1 second, a bit lost here. Okay, this is confusing. This is, let's come back to this example specifically. We have the each. Okay, because it's here. Yeah, the each. I was looking for that. So again, here we're gonna give the reads, descriptive file, and the methods. So these methods, we're gonna receive them and call them mode here, which basically is Salmon or Callisto. And by using this qualifier each, what we want to do is that we're gonna run everything, but for each mode. So we're gonna get all the reads with this transcriptome file, and we're gonna use Salmon, which is the mode here. When all the sample, not specifically waiting for all the samples to be over, but at the same time, we're going to issue tasks, we're going to run tasks, we're going to do everything but with Callisto mode. So basically, we're going to do this command, which is like creating indexes for all the reads, both with Salmon and with Callisto. So it's nice to run this example here because you see that it's not really waiting for anything. It's not waiting for one mode to end to start the other. Actually, they're just like any other task with Nextflow. It's just being ran. So we have here 3 modes, which is regular, espresso, and cycle coffee. And you see sometimes we have cycle coffee, regular, espresso, and then repeated regular, espresso. It's just being called tasks, and the operating system is going to run and handle that, and maybe one is going to end sooner than the other. And here you see we have all the samples. So here's beautiful. At the end, we have the same sample with the 3 modes, but sometimes a bit more messy, as you see here. So this is what we call a repeater, an input repeater with each. So the magic here happens because of this qualifier, each. For output, we already saw that. We have an output qualifier, an output name, that we're going to use in the script block other place, but we can also use emit if we want to give a name for that, a better readable name. So here we have a simple case. We have an output being a value. Whatever happened here in the script is going to be captured and stored to this X, which is going to be the output channel. So just we save it to a channel here, and we can see here. We're going to use this closure just to have received and the content, but it's same thing as we saw before. It's going to print broad, DNA, and RNA. We can also have a path here. We're going to say the path between quotes. It's a file named result.txt. It's not like a variable that we create. It's really, this is the name of the file. And just like we can have multiple input files, we can have also multiple output files. So here is an example that Evan showed you in the first day, that we had a process having different chunk files with parts of the world, the word. I think it was hello world. We have hello world, and then world in the end. So many files being created. So here we have one qualifier, one glob, which is asterisk, because it's going to be chunk 1, 2, 3, which is the way the split software works. Then we can see it here. We can have dynamic output file names that depend on something else. So here, we're going to use X, which is the species, right? Let me see. So when we call a line process, we say the species, we give the species and the sequences. So X here is the species, cat, dog, sloth. So by using this variable here, the name of the output file of this process, because it's a path, so it's a file, it's going to be the name of the species.aln. So you can also have dynamically named output channels, files, and so on. Another thing you can do is to have composite of inputs and outputs. So these are tuples, basically. We already saw that when we were working with file pairs. We had the ID, like gut, and the 2 samples, which were paths. So that's what we have here, a tuple of a value and paths. The output is going to be sample and path. In this case of the band files, which are aligned with some software we would use here on our raw sequences, and we will get the band files. The when we already discussed that. So here we say that if the name of this file, so FASTA is an input path, so we can use .name to get the string of this path. if it respects this regular expression. So don't worry too much here. You can just have a name or an extension. So, but here in the example, they decided to have this regular expression. And the type, it's another channel here for the input, has to be NR. If it's not, don't run this process. Just ignore that. Then we have directives, which are at the very beginning of the process. We saw yesterday a few of them, like CPUs, container, published here. One thing to pay attention, and soon you're going to understand why. So directives are just the name, space, and the value. Because when you use directives in the config file, it's a bit different. You use the equal sign. So be careful not to confuse. It's a very common mistake to do. So here, just a space and the value. So here we are telling the operating system that when we want to run this a task of this process, we want to request 2 cores to do that and 1 GB of RAM memory. And the container is going to be this one. So that's what we do. There are many different directives. Here, just a few of them. There are much more, actually. You can see here in the official documentation, where you have CPUs, time that you want to allow for that process. So if a task takes longer than 1 hour, and you finish the pipeline because it's wrong. It should be less. The amount of memory, the amount of disk, you can give a tag, as you saw before. So if we have a task for many different samples, you can have a tag saying, okay, this run here is for gut, this run is for liver, this run is for lung. We saw that yesterday. The published here, we also saw that. We can use it to say where we want the output file, the results of our pipeline to be stored. We can use stage as to give. So you can use mode to say if you want to copy or to create a link. You can use a stage as to rename the file, some other name that you want. Probably there's one example at some point. You can use the variables here for the subdirectories. You can use patterns. So this process in the end creates a lot of files, but I just want the output files that end with FQ or that have this part at the end or that start with something. So you don't have to save every output file of that process. You could just get the final process in your pipeline and just get part of the output files that are generated. So you can do that with the pattern option. And as I said, you can use stage as to say with a different name. So now we've been for 1 hour talking. I think it's enough so that we have a break now. We're going to do 15-minute break. Again, take some water, stand a bit. Feel free to go to Slack and ask questions. I will also be there to reply some of the questions or if you have some feedback for this part of the course. So we have now 15 minutes. After that, we're going to start operators. Then we're going to go to the modules, Nextflow config, and a bit of deployment scenarios. So thank you for your attention and be right back in 15 minutes. Okay, let's come back. We finished process. Now we go to operators. So we have about 1 hour and some minutes to cover operators and Nextflow configuration and deployment scenarios. Okay, let's close this. Okay, so for operators, again, if you go to the official documentation, there's a very long list of operators, which are basically functions, okay, that apply to channels. So at some point, I was looking at the questions that were asked in the Slack channel, and someone asked what was the difference between a Groovy variable, like a Nextflow variable, and a value channel. And Rob Symes that gave a very good answer. So you need channels to use these operators, these Nextflow operators, which are specific to channels. You need channels to work with them. So if you just had a Nextflow variable, a Groovy variable, you wouldn't be able, or the operators, they would work differently. They would behave differently. So that's why you have these operators. They're not just functions. They're functions that work on channels. Here we have some of them to be shown today. We have filtering operators, transforming operators, splitting operators, combining operators, forking operators, math operators, and many more. So one example, a very basic example here, I like this figure. So you have this channel, which is called nums. Okay, you have 4, 3, 2, 1. It's defined here. So visually we have it here, but in Nextflow, we have nums equal channel of 1, 2, 3, 4. And then you create a new channel, which is called square, which is basically the nums channel with the map operator applied to it. And then you have this closure saying what you want to do with every element of the nums channel. And basically what you're going to say here is that you want it multiplied by it. So the element multiplied by itself.
Marcel, are you sharing your screen?
Oh my God, I'm so sorry. Okay, forgot this tiny detail. Okay, so I was fortunately I didn't show much. Thanks, Rob. So here we have the operator I was talking about. So we have this basic example. So we have this nums channel, which is defined here in text, and we have this map operator, which is basically get the it, which is every element, and multiply it by itself. So there was also another question that I saw on Slack, people asking, what is this it dash larger than here? So if you want to call the element of the channel it, you don't need that. You can just say curly brace, it times it, you close curly brace. This is the explicit definition, and it's useful because if you wanted to call element, so let's do it here so you can see it. This is the explicit definition. And because it is the default one, I can even remove that and it's going to work just fine. Okay, I can remove it and everything is going to work just the same. But if I wanted to call this, instead of it, I want to call this element. If I do it like this, Nextflow is going to complain. It's going to say, what's element? I don't know what's element. Because it is a special keyword. It's no, but what's element? There's no such variable called element. But then what we can do is the explicit version. And then we say, okay, I want to call every element, and then I want to multiply each of them. And by doing that, now it works again. So again, if you're going to use it, you don't need the first part. If you want some other name, you need. But it doesn't hurt to have the explicit version. It's easier to read. So every element is going to be it, and I want it to be multiplied by it again. And then I use the view operator to see the content of this channel. Because nums is a channel, and I'm using this operator, the output is also going to be a channel. It doesn't work like this for all the operators, but for most of them it does. So here's a very basic example of using operators. So let's talk about basic ones. So view, we've seen view like 1,000 times already. So basically view shows us what's in a channel. And again, why don't we just print it? Because as we saw, and we're gonna see again now, the content of the variable that is a channel is a thing that's not for us to see, it's for Nextflow to handle. It's a data flow variable. So if we just tell the println, you're gonna see the data flow broadcast, blah, 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 blah. But with the view operator, we're gonna see every element. And if you run this with GSL1, we can even see the values, even though it's not very readable. We still see here value 1, value 2, value 3, then the poison pill that we are ignoring here. So what the view operator does is to get this information inside these values here. So if you want to see the content of a channel, remember, the operator that you want is the view one. Just like any other operator, we can use closures. So here, if we want, we saw a slightly different example before, where we had something like this. But now we're going to have something slightly different. What's printed here already. So we have every element, where it's going to be a string preceded by this dash. So the map, we've seen it already also. It's going to do something to every element. So here for map, we're going to do with IT, we're going to do reverse to get it, this to reverse the order of the characters in the string. But again, there are two elements. So there's going to be two emissions here. I'm going to have hello reversed and world reversed. There are many other things you can do. So here, for example, you can create a collection in which the first part is the word itself. And here we have the size. This is another nice example, because what we can do here is that we can just delete this and say its size. We just say it everywhere. And why we don't need this explicit version anymore? Because we're going to use it. If we had word, then we needed this first part here. There's a hello contains 5 letters, world contains 5 letters. So the size is a function we can apply to a string, because here it is not a channel. It's an element of a channel. In this case, it's a string. So we can just say hello.size. We're going to get the number of letters, of characters that this string has. Here's a very nice example we have from path, the channel factory. So we get a lot of .fq files. We're going to map, and each of these files, I'm going to use this name, instead of .size, I want to use .name to get the file name and the path here. And then I want to, even though it's a channel with this information, I want to view the content of this channel, and I want it to be formatted because I know it's a name in a file like this, with a column separating the values. And this preceding, the start key at the beginning. So we have the file name and the file path. One nice operator is the mix operator. So the mix operator is very straightforward. It just combines, in the simplest terms, channels. So here we have one channel, which is 1, 2, 3. We have one channel, which is A and B. We have one channel, which is C. And we just can mix whatever many channels we want. So I'm going to do it slightly different here. I'm going to say that this is one element, and 3 elements here. And by doing that, we're going to have 3, 4, 5, a channel with 5 elements, because I made this one single element with the brackets. Okay, it's going to be 1 per line. Okay, that's what view does. 1, 2, AB. Now, if I remove the brackets, then we have 6 elements now. So there's no secret for mix. It's very simple. You just have many channels. You want to create one channel with all the elements of these channels. You're going to use mix. Very simple, straightforward. The first definition of combining is something that comes to mind when you think about it. We have already seen flatten also. So in this case, we could have here 2 elements. So let's see what's going to happen here. So we have foo and bar. Okay, we're going to create a channel which has 2 elements, 1, 2, 3, and 4, 5, 6. But because we use flatten, they're going to become 6 elements. If we don't have the flatten, we would have 2 elements. I'm going to see because it's 2 rows. And view works by having per row sample elements. So here we have 2 elements. But because we have the flatten, it gets everything in a single element in the new channel. And that's why we have 6 lines, 6 elements. So as we've been saying, like this, all these operators, they have channels or elements and stuff. Collect is a bit different. So actually collect gets a channel and turns it into a list collection of values. So it's not really a channel anymore in a sense. So here we have 4 elements, and after using collect, we're going to have a single element. And you're going to see that because it's a single row, it's a 1-line output of view. Group tuple is very interesting. So if you have tuples with a key, you can make them. You can group all this. So you have one channel with 1, 2, 3, 4, 5, 6, with 7 elements. And because they have a key, which here is the first element, you can group them in tuples. And how are you going to do that? So not just going to merge them or anything. I'm actually grouping them as a tuple based on the ID. And here is a tuple because you see there's an ID 1, and then a tuple which is a tuple with 1 as 1 element, and all the other values as a second element. So for 1 we have here 1 has A, 1 has B, and here 1 has C. So for 2 we have 2C here and 2A here. For 3 we have 3B here and 3D here. So the group tuple does that. It gets the first element of the tuple, which is the ID. It looks for all the other ones with the same sample ID and gets together the second elements of these tuples. Join is a bit similar, but we have only one channel here when we use group tuple. So group tuple works with one channel. For join, it's 2 channels. So it's a bit similar in the sense that I have a channel left, a channel right, and I'm going to join them based on the key. But it's 2 different channels. So let's see what's going to happen. Basically, we have X here, which X has 1. In this case, X has 4. So we have here X14, the output. So for Z, Z has 6 and Z has 3 here at the top. So Z is going to do 3, 6. And Y is 2 and 5. So Y2 here, 5 here. Sweet. So if you want to group by a key and you have a single channel, is group tuple. If you have more than one channel, you're going to use join. Another very interesting operator is branch. So the idea of branch is that the way your workflow works can be dynamic, can be conditional, just like we had the when before, when a whole process to run. But here it's within a process, or not even a process, we want things to go one way or the other, or even more than that. So here we have, for example, a channel with these values, 1, 2, 3, 40, and 50. So 5 elements. And we're going to use the branch operator to say, if the element for every element of this channel is smaller than 10, I'm going to call this small. It's one branch of my reasoning, let's say. If it's larger than 10, I'm going to say it's large. And I'm going to store the output channel. This channel itself. I create the channel, I operate it with the branch operator, and then I store it to a variable, a channel called result. And then by using the dot and the name that I gave, small or large, I can do an operator or pass this to a channel for the subset of this category. So here, when I use the view operator, it's only going to be used in the elements of the small category. Let's think of categories. I think it's easier to understand. And large for the ones that are large. So what we can do here, and again, we're using a closure here to add some text. IT is small, not only it, but it's small, it's large in a string. Let's see what's going to happen. 1 is small, 40 is large, 2 is small, 50 is large, and 3 is small. So this is the branch operator. As I said, there are many more operators that you can look for in the operators documentation. In the official documentation is docs.nextflow.io. There are many more that you can use that. A section with Groovy, we decided to skip that because of time limitations, okay? But there are many things you can learn here, how to create closures and many other things. Let's go to the next section, which is modularization. Okay, so modules and modularization in general was something brought by DSL2, which is the latest version of the Nextflow language. So I'm not sure if it was clear at the beginning, but Nextflow is a language, is a domain-specific language for writing pipelines. And Nextflow is also the engine, the software that runs this pipeline written in Nextflow. So it's two things, okay? And Nextflow is a language, it exists on top of Groovy, so the superset of the Groovy language. So it's very, very powerful. It's not just like a very dry description language of pipelines. It's really a very powerful programming language to describe the pipeline, but also to do a lot of things with it. So the idea here with this modularization is that you don't have to have this huge script file with a lot of things. Not only we decrease the size already because a few things like configuration we put to a different file, but we can have so many different processes. And not only we should decrease the size of the file to make it easier to read and to understand, but also there are many other people that need to use part of your pipeline, for example, and it would be nice for them to easily import this part. So what we can do here is to go back to an example that we saw at the beginning with JSON. And we were talking about how to parse a JSON file in your pipeline and also YAML one, but you don't want to have this code here in your pipeline because you want to focus on your pipeline is doing, not how part of it is parsing a type of form of file formats. So what you can do is that you can create a file called parsers.nf, for example, and inside this Nextflow file, you have all these scripts for parsing YAML, JSON, or whatever you want, or some very specific things that someone may want to add to their pipelines. And by having this in the file, you can just use this expression here to include, and then you say the name of the process that you created from the file. And automatically you can use this, you can call this process or this function or anything in your code. So here we have general from path, you have a flat map. In this case here, every element is going to be parsed to this function. And then you're going to do what we did before by getting the entry and with the name of, in the case, feature or patient in the field of the JSON file. So let's go back to modules. This was just one example of how you can use modules. Modularization, okay. So you can have like the first example we had at the beginning with the split letters and convert to upper that Evan was teaching. We can save it in a different file. And then in the current pipeline file that you're writing, you can just include them and you can use the process without having the definition, the description of the process in your current file. So here's one example. The final one would be like that. So we don't have any process in this workflow file here. All the processes that are being imported. You just have your workflow block. And in the modules.nf file from where you're importing, you have just the processes. In this case, split letters and convert to APA. So you don't have to have this like two lines, like import split letter from this and convert APA to the same file. You can just import all these processes from this specific file. And even though it was called like that in the module, you don't have to use the same name. You can use alias. So import split letters as, and you can put in your language, for example, or another name that you think it's easier to understand from this file, and then you can use it. Sometimes, and this was also a question that came up, I think this morning maybe, or maybe in this training, I'm not sure, that someone wanted to run a process slightly different 2 times. So what you can do here is that you can include the split letters, and you call it split letters 1, and split letters again 2. And for example, it could be the mode, like you want to run once with Callisto and one with Salmon. And you could have like a branch for, depending on the quality of the sample you want to do with one way or the other, depending on the size of the transcription reference, and so on. So you can have this AS as S. You can do this to create new names for a process that you're importing from a module. And here you have your workflow block calling all these guys. And as you can see, there's no process block in this script file. All the processes are being imported from the modules. For the output definition, there are many ways you can get the output. Like so far, what we've been doing is this way. So we create a channel and we save it to a file, to a variable. Then we call a process with this channel and we save it to another channel variable. Then we call another process with a channel variable and we save the result to another channel variable. And then we use view to see what's inside this channel variable. So I think it's very clear. It's easy to understand, to read, but it's very verbose, if you know what I mean. So what we can do actually is use this dot out to get the output. So I don't have to save every process that I call, I don't have to save it to a variable. I can just use the dot out to get the output. So here, for example, the split letters, I could just have that. So let's do actually this, but then I would have to import. So what I want to tell you is that here we saved to letters underline CH, and we could just use it, but instead we could just get this dot out. It's much easier to have here like this. So I don't have now the channel variable that I created before to save the output of this process. I just call it with dot out, and automatically I will get the output of that. And again, here I'm calling another process. I can just again use the dot out to get the output again. So it works like that. You have to write less code. It's simpler, but it really, again, it's a matter of taste if you like it to be more explicit or not. But then one thing you can say is like, okay, Marcel, so convert. So depending on my process, I can have one output, but sometimes I have many outputs. And with dot out, how can I choose which output I want to see, or apply an operator, or give us input to another process, and so on? Because you could have a process A that has two outputs, and one output is the input for process B, but the other output of process A is the input for process C. So this way you can use with the brackets and the 0, 1, and so on. You can say which of the outputs you want to work with. Another thing you can do is that you can rename an output. So here, convert to upper, it's going to write to the standard output. And it's going to print in your screen if you have the book true, or dash process.echo. But another thing that you may want to do is to use emit to give a name to that. In the case of standard output, standard std out is a keyword, is a reserved keyword, but then you can use emit to just give a nice name to it. And then you can use, like here, convert upper. I want the output, okay, it's not out, but I don't want 0 or 1. I don't want to use these positional numbers. I want to use the name of the output. But then std out you can use. So by using the emit, you have upper, which is much easier to see, to understand. Another thing you can do, instead of all this parentheses and more parentheses and more parentheses, actually we could just have here convert upper, parentheses, split, and then greeting ch, and then channel off. You could have like a very long line of code with all these combinations. Here we make it simpler by splitting by line, but another thing you can do is to use pipes. So I'm going to create a channel that's going to be passed to split letters, that's going to be passed to a flatten operator, that's going to be passed to convert to upper, that's going to be passed to the view operator. So you can also do that. Here it's a bit long. So usually what people does, something like that. So it's easier to read. And the length of the lines is shorter, it's easier to read. Another thing that you can do actually is that you can have different workflow blocks in your pipeline script. So you need to have only one unnamed, which is always going to be called by default, but you can have named pipelines, named workflows. Here we created one called my pipeline. And then you could have many of these sub workflows, and your implicit workflow, which is this one, the unnamed one, is going to call all of them. And the nice thing is that actually you can also use Nextflow run. You can use like entry. So again, one dash, it's a Nextflow option or parameter. Then you can use entry to choose what workflow, sub workflow you want to run. Sometimes you may want to use one or the other, a longer version, shorter version, and so on. For inputs, sometimes because you have sub workflows, you are calling them with your unnamed one, with this one here, you may want to pass an argument like a channel or something. So if you do that, you have to get a take block in your named workflow. So here we are saying that it's going to take an input called greeting. And then when you work your unnamed workflow, you pass something. Whenever you use the take, you have to have an explicit main block with saying what processes are being called, what's going to be done in the sub workflow. Here we have everything together. So I'm going to emit this output. I'm going to call it my data. So that's why here I can use out and my data and then deal. So it's a sub workflow being called by my unnamed workflow. This is what I said a while ago, but entry, you can use the dash entry to choose which pipeline. You can have like a sub workflow, my pipeline 1, a sub workflow, my pipeline 2, and then workflow calling everything. But maybe today you just want to run this one or this one. And then you're going to use the dash entry option of Nextflow, like here. This is already written, I don't know. Yeah, so I would have to write it. It's fine. So for this parameter scope, when you import, so this is your modules.nf. Here's your main one. You are including the process say hello. But again, here in your script file, you have Hola Mundo as the default parameters. And in the modules one, you have hello world. So sometimes you may want to have the default from the modules, not from your script. And what you can do is to use this add params. So I'm going to include say hello from module F, add params, and I want foo to be this value. I don't want Hola Mundo as I have here. Maybe I want to use this for something else. So I'm going to use Hola, and then I'm going to have Hola Mundo. So now let's go to the, not the last one, but almost the last one subsection. So we're going to go to Nextflow configuration. We've seen already. Give me 1 second to have some water. So we've seen already that it's ideal to have the configuration of your pipeline in a configuration file so that you only have in your pipeline script things that are really related of what's going to be run, how, and so on. And usually we have the nextflow.config, but also the .nextflow/config in your home directory. So as I said earlier, you're going to have in your process the directive name, like container, space, and the name of the container. But if it's in the configuration file, you have to have equal. And actually, you saw that already, because yesterday when we worked with containers, we had this. The container was this. And because it's a directive related to processes, you have to have this prefix here, process.container. So this says that for every process in this pipeline, in this folder, we're going to use a container. And this is the container image that's going to be used. So you can create some config variables like that, always using the equal sign, not only space. You can give comments in your configuration file like that. A single line comment is 2 slashes, otherwise it's like that, slash star and star slash. You have some scope for configuration. So I think someone asked about that in this on Slack. I think Ben replied with a link showing all the priorities of whose scope comes first and so on. We already saw that, the parameters. See if there's something interesting here. We can set environment variables this way in your config file, m dot and the name. And you can set them like this in the process itself. You can load an extra config file with -c. Actually, you can do Nextflow -h, and you have two. We have uppercase C and lowercase c. So for the lowercase c or config, you add the file you brought to the configuration that's already there. So you don't. It's not like a fresh configuration. You have a lot of things already set, and you want to add more things. You use -config. If you use -uppercase C, you're gonna override the defaults. So be careful between using the uppercase C and the lowercase c, because they are different. So we saw that we could set some directives like CPUs, memory, container, time in the process itself, but also in the configuration file. So this is the configuration file. So I could just have process, container, something like we have here, or process CPUs. We have something like this. All the processes in this pipeline are going to run with 2 CPUs. But if I, instead of saying this, okay, and then process memory, instead of saying that a lot of times typing process, I could instead do like this. Use 10, memories for gigabyte, container, some image, time one. You know, you could. It's much easier to just have this structure here for all the processes. But one thing that you may think of is like, okay, but you know, I don't want all my processes to be like that. And you can use then process selectors. Let me find them here. So by using process select, I jumped, skipped it. Where is it? Okay, process selector, where's the example? Okay, we're soon gonna get there. So the thing is, you can also use some variables like test CPUs to set things. So you can have memory like that. Instead of memory being always 1 gigabyte, which doesn't make sense because if other things change, you may also need to change memory. You can say that actually I want 4 gigabytes in memory times the number of CPUs that the task is using. Is going to request to use. So if we have CPUs 1, it's going to be 4 gigabytes. If we have 2, it's going to be 8. You can also have attempts. I'm not sure if there's an example here like that. There is in the official documentation. But basically, you can have, okay, run this task with 1 gigabyte of memory. If it fails, try with 2 gigabytes, and then with 3, and so on. So you can do things like that. You can also have process selectors like with name. Where is it? Okay. Oh, okay, so this is in the next section, but actually it should be here. So what you can do is that you have like this. This is a very nice example. So you have the process block in the config file saying that, you know, all your processes, they will run, they're going to have 10 gigabytes of memory on the request, 30 minutes, and 4 CPUs, except processes with the name full, because in this case, I want 2 CPUs, 20 gigabytes of memory, and that's it. So this Q thing, I'm going to talk about it soon, not now. And if it's the process with the name bar, then I want 4 CPUs, 32 gigabytes of RAM, and that's it. Another thing that may be a bit more interesting is to use, instead of using with name, that is the name of the process, we can use with label. And that's a bit more interesting because you can, like in your process, You have some process, foo, blah. You can use a directive label and say like long or short, and you can give this label to many processes. So I may have 20 processes and 18 of them are quick. So I'm going to put the label short, but the rest, a few of them, they are very long. So in this case, I'm going to use the long label for them. And then what happens here is that I always want 10 gigabytes of memory, 30 minutes for CPUs, but when the label is short, I want to be it like that. And when the label is long, I want to do like that. So this is another way to configure processes in your configure file. And there are many other ways that you can do that, actually. Let's go back to where we were. Was here. So another thing you can do is that you can set the number of times you want your task to retry. So you have your process definition, then you have a channel with some elements, then a new element comes, your process creates a task and runs it. For some reason, it breaks. There's an error or something. It can automatically retry with the same sample. And you can set how many times you are willing to retry with that sample. Here is 3. So if the third time breaks, it doesn't work, the pipeline will fail, will stop, depending on your error strategy. But for now, let's think it's going to stop. There is a way, another interesting directive for processes. We already saw that many times. A container, we want the Docker to be enabled by default. Instead of the name in the namespace of the, instead of just the name and names, instead of the namespace and the name of the container image, we can also use ads in the hash ID of the image to make sure that we are always using this specific version. For reproducibility, this is recommended. You can also do that for Singularity, which is another container technology, and many other things. Here's same thing. For Conda, we can also use for a process. We used Conda before. We can say, where is your environment for the packages you installed? Okay, I'm going to do a 10-minute break. I think it was a bit intense, this config part. Probably there are some questions. I'm going to do a 10-minute break, and then we come back for the last part of the session today, which is deployment scenarios. Okay? So 10-minute break. Okay, so let's go back to where we were. Let me share my screen. So now we're going to talk about deployment scenarios. Okay. So the idea of deployment scenario is that a lot of times people will develop their pipelines in their local computers, in their laptops, desktops, and so on. But not always they want to run it locally. So usually you're going to run it in the cloud, in a local cluster in your company or university, an HPC cluster, or maybe some hybrid format. But usually you want to deploy your pipeline to run somewhere else. So here, maybe the most common for universities is changing, but still I think the most common is to have a cluster, an HPC cluster. Probably they're going to have Slurm or PBS, something like that, to as a job scheduler, so that you connect to your cluster, you submit the job, that whenever there are some resources available, the cluster will manage the execution of your job. So what we do here is that Nextflow can run locally, as we've seen, but it can also work with all the main technologies. So if we go to nextflow.io, we can see here, I remember having a picture here somewhere. Anyway, so Nextflow works with main technologies of cloud providers and also HPC clusters. So PBS, Slurm, most common ones we support it. So basically, you can just connect to the head login node, the login node, and run Nextflow, and it will, without you have to do anything, it will submit the jobs in the local job scheduler like Slurm. However, that's not really a good practice. Usually, the nice thing, ideally you would submit Nextflow as a job, like you would do with any other job. But then as a job, Nextflow will manage and submit other jobs. So then you have the local OS in the cluster, you have the batch scheduler, which is the Slurm, for example, PBS, you have some file system, storage, and so on, and everything is going to be done there. To do that, to tell Nextflow that you don't want it to run locally in your head login node or in your local machine, but actually in a HPC cluster, you have to tell that the executor for other processes is Slurm, for example. So it knows how to work with Slurm, or PBS, or any other example, Kubernetes, or in the cloud, AWS, and so on, Google Cloud, Microsoft Azure, and so on. But then you also have to manage the resources that you need for each job, just like we did for our machine locally, or we have to do in the cloud. So sometimes you have queues in the HPC clusters, or even in the cloud, it depends on the provider. But again, you have the CPUs, the memory, time, disk, and so on. Everything we've been talking so far. And then as we saw in the config section, which was the previous one, we can set the memory for that process, the time, the CPUs, now also the queue in the cluster, and the executor we want to use. We also saw the with name. So all the processes with this name are going to have this directives. With this name, they're going to have this directives, and all the other processes are going to have this directive. Here for the one with the pipeline we built yesterday, we could just say the quantification process, I want to have 2 CPUs and 5 gigabytes. Everything else, I don't want to say anything. And by default, the CPU 1 is 1, and so on. You can use labels, as I saw, as I showed before. If it's long, this process is going to be long, so we're going to do this for long, this for short. So for short, just 4 CPUs, 20 gigabytes. But for long, I want much more, okay? We can also have multiple containers. It's something I think someone asked yesterday. I could have the process foo. I want this container image, but the process bar with the name bar, I want this image container. So you can set which ones you want. You can have one container per process, which in most cases is the right thing to do. There's some explanation here why there are pros and cons for fat containers and simple ones. You can also have some profiles, and this is very common in NF Core pipelines. You have like a test profile and so on. You could have, for example, a pipeline that you wrote. When you want to run it in your machine, you say that you want the standard profile. When you have the standard one, you don't have to set. So you would just say Nextflow run my pipeline.nf, and automatically the profile would be this one, which is the local executor, and the genome is in this path. I don't have to say where the genome, the reference genome is, because it's here, it's always there. But I can also say I want as a profile cluster. And when I say that, it's going to use SGE, which is a batch scheduler. It's going to use the long queue. I want 10 gigabytes of memory. I want to use this conda environment, and the genome, the reference genome file is going to be here. If I say cloud, in this case, I want AWS batch, this container with Docker, because it could be Singularity or other container technology. So here I'm saying that it's Docker, and the genome reference file is here. Of course, you have to set your AWS batch keys, sequence, and so on. But here, just how it would look for setting the profiles. And then you could just say run cluster, or you could say run standard and cloud. And here for standard, it's basically where the genome is. Here, it's going to override the last one. The queue here, container, work there. There are many things you can do. You can choose the AWS region, the CLI path. So if you go to the Nextflow blog, nextflow.io, and you go to blog, you have many nice blog posts talking about how to deploy Nextflow pipelines with Google Cloud Batch. You also have with Windows, how to use the SQL, many tips to use Nextflow in HPC clusters. More tips here. You have for using Nextflow in Azure batch. You also have for AWS batch somewhere. Anyway, if you go to the Nextflow blog, the official blog, you have many tutorials with code and pictures and everything telling you how to use Nextflow on the cloud, or how to tips to use it on HPC clusters. You can also have volume mounts, like with the EBS from AWS. You do it like that. So AWS, batch, and you have your configuration. You can have the region. You can have some custom job definitions. So there are many things you can do with cloud providers. And then it's a thing, like we support the main cloud providers, but still everything is a bit different. Even though it's supported, you have to see like in the blog post or in the official documentation. I keep talking about the official documentation. Is docs.nextflow.io. So here you have everything for Amazon Cloud, everything for Amazon S3 storage, everything for Azure Cloud, Google Cloud, things like Apache Ignite, Kubernetes. Have many things here. So it's a very long document with things about a lot of cloud providers, and also other things that we were talking. So we mentioned Project Deer at some point, but you see there are many others workflow variables, objects that you can set, and not set but consult, like when it was used and so on. So it's a very rich material, the official Nextflow documentation, and you definitely should check it. So the training material is very nice, but again, it couldn't be so long. So we had to focus on a few things. So a lot of interesting things you can do with cloud, you're going to see actually tomorrow. So Evan is going to talk about Nextflow Tower, which is a platform that allows you to, from your computer, to run something in the HPC. Because usually you have to connect to the HPC cluster of your institution, and from there connected, you run your pipeline. But with Nextflow Tower, you're going to see today, it's much easier. From your computer, you can run something that's going to partially run in your computer, partially run in the HPC cluster, partially run in Azure, partially run in Google Cloud, you can really make hybrid deployments. So here, for example, whenever there's the big task label, it's going to be AWS batch, but otherwise, it's something else. I don't know. It's just many different examples you can think. So I think it's that for today. If you have any question, you can still ask in the Slack channel, even like now or until like tomorrow during the training, after the training. Feel free to ask all your questions. We'll be delighted to help. I hope you enjoyed the second session of the training. I'm very welcome to feedback. If you have anything to share, something that you think could be done better, don't hesitate to get in touch. And it was great to have you all here. So have a great day and keep learning Nextflow with the documentation and the training material, going over what we said today, and also in the documentation and so on. So see you.